Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Faris bin Nasaruddin and my number matrix is MA24009. So today I'm going to present introduction about Six Sigma and his main five phase, which is DMAIC. So what is DMAIC? DMAIC is stand for Define, Measure, Analyze, Improve, and Control. Okay, so here is the infographic about five main phase of DMAIC. So it is follow first by define. So Six Sigma is a, a continuous work that finding and solving the problem. So in Six Sigma, we have five phases, which is first we need to define the problem. We need to clearly state the issue, customer requirement, project goals to create a project charter. And then we follow with a measure to measure the current performance or the current result or current um, data that has been produced by marketing or producing by machine or manufacturing. So we collect reliable data to establish a performance baseline and quantify the problem scale. And then we analyze the root cause. We need to find the real concrete problem to solve and to improve the current process, which is we use the collect data from the measure phase to identify, validate, and select the root cause of the issue. And then after we find out the problem, we improve on solving the problem. So in this phase, we brainstorm, test, and implement effective solution that directly address the root cause. And then after improving and solving, we need to keep the new um, new solving solving method to continuously work. So we implement control state, which is uh, control the future state. So we create monitoring plans, standardize the new process. We create SOP to sustain the gains achieved. Okay, so what is the benefit by following of the MAIC? So there are many benefits that can be gained, and one of them is we can provide a structured approach. So we can um, solve, define, we can analyze in a structured manner. So we offer a clear roadmap for solving complex problem from beginning to end. So and then we also gain enable data driven decision. So we help identify the exact root cause to ensure enhancement outperform previous strategies. And then we also can increase productivity and efficiency. So by following Six Sigma method, we aims to eliminate waste, reduce uh, reduce what we call it in reduce unnecessary spending and shorten process cycle times. Okay, and now what is Six Sigma? So Six Sigma is a symbol. So it is a statistical symbol for standard deviation actually and representing measure of process reliability. Six Sigma also is a benchmark. So it is a specific goal for process capability, demanding nearly defect-free products and services. Six Sigma is also a philosophy where we guide management principle focus heavily on boundaryless collaboration and variation reduction. Six Sigma is also a method where we a well-defined toolkit using the fundamental equation y equal to fx for quality control, improvement, and strategic planning. So Six Sigma is introduced in early 1980, but in the Motorola origins, and then after that it's modified by Deming Plan to Check X Cycle by Bill Smith, where he is currently known as father of Six Sigma. So he is one of the important figure that developed the methodology or base framework for Six Sigma. And then in the 1990, Six Sigma expand beyond manufacturing into service, healthcare, and finance, and often integrate with lean principle. Okay, so Six Sigma. So why we call it Six Sigma? So actually, have a six Sigma, which is we start with one Sigma, two, three, four, five, and then six. It's just when you actually one, we start with we start to detect around 991 and 462 defect per million, and then we try to be specific as possible until we reach 6 sigma, which is the best, uh, where we detect 3.4 defects per million opportunities. And there are also the bad hierarchy, where when we learn the Six Sigma, we start with green belt, where the core project team members train in foundational tools, and then we up to black belt, the project leader and team facilitator highly trained in methods, and then we move to master black belt, highly skilled coach and mentor for black belts, and then champion, where we are able to identify high impact project. We coach teams that require 30-hour course, and then finally the peak of the hierarchy is executive team, where we can set strategic direction and prioritize core business issue, requires an 8-hour implementation roadmap. So this is the five main phase of DMAIC, where I have explained earlier: define, measure, analyze, improve, and control. So now we will go deeper in each phase. So define, define phase. What is define phase? And define phase is the first step of this Six Sigma, where we define the project charter. Define, we state the problem, and we follow the SMART framework, which is SMART stand for specific, M measurable, A achievable, R relevant, T time bound. So SMART framework is the um, what we call it, the standard to define the problem, where the problem statement must be clear and brief description of what the problem is, how often it occurs, and what the impact is when it does occur. So it is a genuine focus on the customer, and proactive management begins with a perfectly scoped problem. So there are several tools to help us define the problem, which is VOC, voice of customer, or we can also call it surveys, and then Kano model and affinity diagrams, CTQ tree diagram. CTQ is control to quality, and then Pareto charts and prioritization matrix. So each tool produce different operational output, where VOC mainly focus on raw customer feedback and market requirement. Kano model, categorization and prioritization of customer needs. CTQ diagram translate broad customer desire into specific, measurable performance requirements. And then the lastly, Pareto charts identify the vital few problems over the trivial many to narrow project scope. So by studying and master each tool, we can use it differently depend on the situation. So how to capturing the voice of the customer, which is VOC. So this is the chart for VOC performance, which is on the y-axis. We measure by customer satisfaction and dissatisfaction, and the x-axis we measured by execution. To the right, excellent execution, and to the left is poor execution. So VOC, uh, we must be fulfill a basic requirement the customer assume will be present, and the satisfier fulfills state performance requirement, which is the blue line, fulfills a state performance requirement, linear relationship with satisfaction, and then delighters, which is the green line, goes over and above requirements for providing the wow factor. So VOC is captured via complaints, focus groups, competitors analysis, competitor analysis, and the Kano model prioritize this feature to map CTQ characteristic. So we by using this chart, we can identify which process is already meet the customer requirement, or which process that need to be improved. So we can also prioritize which one that need to be improved first. Okay, now we move to measure the second phase of Six Sigma. Okay, so measuring current performance. So this is a phase where we collect data and measure the current available present performance, to where we data and fact driven management requires establishing a rigorous as its performance baseline. And by if we don't have a solid data, we cannot improve, because there are no standardized measurement or standardized base that to differentiate the improved one and the current one. So three pillars of measurement, which is first identify metrics. So we translate the CTQ from the defined phase into key performance indicators KPIs, and then define operationally, where we remove ambiguity so that every team members measure the exact same way. So we have the we standardize each work, so there are no different calculation in team members. And then we also collect data, where we execute structured sampling plans to capture real world performance without bias. Okay, process capability and stability, LSL, lower specification limit, and the USL, upper specification limit, and the middle is mean. So what we need to achieve is the where in the stable process, a process is termed in statistical control when only common cause variation is present. The output is must be stable and predictable. And then the process capability measured by the CP and CPK. This express how well the process perform with respect to customer requirement. And then the last, the yield factor, where we calculate the roll throughout yield RTY to understand the true compound defect rate across multiple process steps. Okay, this is example of toolkit for measure phase, which is data collection, first data collection and sampling plans. Second, measurement system analysis, MSA. Third, process capability, CP and CPK. And the last one, roll throughout yield, RTY. And then each tool produce different output, where data collection is a structured framework detecting how, when, and where data is gathered to ensure statistical validity. So um, MSA validate the reliability of the measuring equipment and the appraiser, ensure variation are from the process, not the measurement tool, and the process capability, where we calculate using a given formula to produce output within specification limit, and then RTY, where the probability of single unit passing through all process step completely defect free. Okay, now after we measured, where we collect, after we collect the data, now we move to third phase, which is analyze. So this is the phase where we must translate the SE state from the measured phase to the specific variable that causing defect. So this is the simple guideline where we map the exact current process and then identify all potential failure modes and ways, and then we statistically prove which variable are the true root cause. So here, the analyze toolkit for analyze phase is where which are failure mode and effect analysis (FMEA), hypothesis testing, analyze of variant ANOVA, and also scatter plots and correlation. Failure mode (FMEA), a systematic proactive method for evaluating a process to identify where and how it might fail and to assess the relative impact of different failure. So this tool, we list all the problem of the in the process, and then we try to find out which problem is the most give the highest impact. So by identifying this, we can scope out and narrow the scope to solve the uh, which which problem are more important to solve. And then hypothesis testing, statistical confirmation proving whether a specific variable truly impact the process outcome. This is where we test our hypothesis. And then ANOVA, to determine if there are statistically significant difference between the means of three or more independent groups, and then correlation or scatter plots to visualize the relationship between two variables to identify pattern or potential cause, which is actually identifying noise variables. So analyze phase also is a phase where we mapping and eliminate of waste. So as we can see, if the process before is the hidden inefficiencies, now after the analyzing phase, we change into more structured one, such as value stream mapping (VSM). So in this phase, we focus to drive for perfection with a tolerance for failure, and the team must have the freedom to try new analytical approach. Okay, now we move to improve, which is the second last phase, improve. Um, this phase is after we can narrow, or we are able to identify the problem. Now we can start to improve. So this phase is the phase where we develop, select, and implement the best solution whilst aggressively controlling implementation risk. So, in this phase, we start with brainstorm to generate potential countermeasure, directly targeting the statistically proven root cause. And then we select and prioritize solution based on cost impact and deployment speed. And then we test the solution in controlled environment before full-scale rollout. Okay. So we optimizing the solution with DOE. So what is DOE? DOE stand for Design of Experiments. So it is a systematic method to determine the relationship between factors affecting a process and the output of that process. So why this why this method is matter in this phase. So instead of changing one factor at a time, which means interaction between variable, DOE allows team to manipulate multiple variable simultaneously. So let's say if in the process there are two problem, so instead of we uh, tune one problem and then the one problem will cause another problem. So DOE enable us to tune two problem at once. And then the key output is to identify the critical factors, determine the best settings for those factors, and build a robust process relatively insensitive to environmental noise. So this is the toolkit for improved phase. First is full or fractional DOE, full or fractional factorial DOE, and then response surface methodology, pilot trials, and implementation plan. So each tool produce different output, of course. So DOE produce statistical model that reveal exactly how multiple interacting variable affect the final product. Response surface methodology produce advanced mathematical modeling to find the absolute peak optimal setting for a process. And then pilot trials, where we test in a real world small scale testing of the proposed solution to validate improvement without disrupting the entire operation. And then implementation plan is structured, scheduled, rollout strategy, managing resources, communication, and operational shift. All right. Now we move to the last one, which is the control. Okay. So this phase, control phase, is the phase where after we are able to solve the problem, we need to maintain the so that the problem the new solution one can be uh, can work for a long time and will not cause another problem. So in this phase where there are no improvement, uh, in this case is where improvement is are meaningless if the process degrades back to its original state. So this phase embeds the new process into the organizational DNA. Okay. So first, this is sustainment strategy. So first document where we rewrite all standard work to reflect the new process, and then monitor. We also after we use the solution the process that we have solved. So we also need to collect the after data to catch deviation immediately, and then we also need to recheck periodically and run measurement system analysis to ensure tools remain accurate over time. Okay, so this is the toolkit for control phase. Is first standard operating procedure (SOP), second statistical process control chart (SPC), control plans, project summary, and lessons learned. So SOP is a step-by-step instruction compiled by an organization to help workers carry out complex routine operation perfectly. So after we use give the solution process, so there must be followed by new SOP because different solution has been implemented. So different SOP must be followed up by the workers, and also an SPC is a continuous visual monitoring of process behavior over time to detect shift before they produce defect. So this is where we monitor the current the solution one, whether it will cause another problem or it will help the manufacturing or any um, any process improve. And we also can by monitoring the data, we can also differentiate uh, the current outcome the new outcome and the previous outcome. And then the control plans is a master document detailing the action required at each phase of the process to ensure all outputs remain in a state of control. So this is a tool where we can ensure that there are no uh, change variable in our new solution. And then project summary and lesson learned is an archival document capturing the methodology, success and failure to accelerate future Six Sigma projects. Okay, so we move. Now we has reached the conclusion. So the five laws of Lean. So there are five laws of Lean. First is the law of the market, which is the base law, where the customer is critical to quality, CTQ, and the highest priority for defining value. So, um, obviously, the Six Sigma or the process uh, is must be based on the customer. If the customer is okay, now the process is actually is good. But we need to look at the second law, the law of flexibility, where the process speed is directly linked to process elasticity. So the process must be flexible. It can adapt to anything, or uh, it uh, it can what we call it. It is durable to any change of variable. If the second law is good. Now we move to the third law, the law of focus. The law of focus is 18% of issues are caused by 20% of activities. So we need to target the certain variable to maintain the process. And then the law of velocity, which is high work in progress, WIP, leads to queues and drastically increased lead time, where the process must be quick or as soon as possible to reduce the time taken. So uh, the more fast it is, the more lean of the process. And then the fifth law, which is the complexity and cost. The more complex a product or service, the more it will cost to deliver. So the more complex the process the process needed, it is also will increase with the cost. So DMAIC is also a continuous cycle where we start with define and then measure, analyze, improve, and control. And if we still have a problem, so we define the problem again, and then we measure, analyze, improve, and control, and so on. So this is a continuous cycle until we achieve um, the ultimate solution. So Six Sigma create more value for customer with fewer resources by relying on a set of driven techniques and implement required dedicated change management, leading to people side of change to achieve the desired numerical outcome. Uh, and also DMAIC is not a one-time project, it is permanent operational rhythm of a mature boundaryless organization. Okay, so this is the reference uh, from my presentation. Okay, so that's all from me. Thank you for listening to my presentation about introduction of Six Sigma.